Hello, my name is Taylor Segal, and I decided to do my project on candles and their composition and their reaction processes. So, as we learn in organic chemistry is the study of the structure, properties, and reactions of organic compounds. And of course, organic compounds are molecules that are made of carbon to carbon bonds or carbon to hydrogen bonds. So, first, we're going to look at the wax of candles and what they are made of. There are candles that are made from different types of waxes. The most common is beeswax, or what's called microcrystalline wax. But present day, the most commonly used wax is called paraffin wax. And paraffin wax is mainly contains a molecule called heteroxyphene, and it is a very long straight hydrocarbon. It consists of 31 carbons and 64 hydrogens. Not all paraffin waxes contain that specific molecule, but today we're going to talk about that one. One of the general formula used to find what the hydrocarbon chain, like how long it is in the wax, is using CnH2n plus 2, which we learned in class. Next, I'm going to talk about the wick, and it's important in the reaction process for the candle. The wick is normally made of cotton fibers that are braided to help help support the wick. So whenever you light a candle using the wick, if it'll light, there it goes. What happens is the bottom portion of the wick heats up really fast, and the wax will start to melt. And the melted wax will actually move up the wick, because the wick acts as a capillary, and as the melted wax moves up the wick and is heated up through the flame, the melted wax turns into a vapor or a gas. And this is pretty cool. So what also happens during this process, you have your organic compound in the wax, which is the C31H64. As it heats up and reacts with the flame and the oxygen in the air, it goes under a combustion reaction. It produces carbon dioxide, heat, light, and water vapor. And one way you can see this is by taking a glass and placing it on around the candle. You're basically, the flame will burn out as it consumes the remaining oxygen in the air, and eventually once it fully burns out, you will see a formation of water vapor within the glass. It normally takes a while. You can't see the carbon dioxide, but it is cool that you can see the water vapor. And this kind of just shows more of what kind of process is taking place in this example. Also, if we relight the candle, if you take an object, let's say a spoon, and you place it above the flame and you hinder how much oxygen the flame is receiving, this is called an incomplete combustion reaction. So instead of carbon dioxide forming and water vapor forming, you're actually just going to see a black substance form, which is the carbon. Since you don't have the oxygen reacting in the combustion reaction, you only have carbon being produced. So now we're going to talk about the scent of candles, how they're made. A lot of candle scents are made from synthetic compounds, but a lot of them are also made from essential oils, and essential oils contain organic compounds, but the way The way these organic compounds are extracted is through a similar system that we did in lab using simple distillation, but instead it uses steam distillation. So the setup looks very similar to what we did in lab, except we also have a separatory funnel here that acts as another water source. What happens is you're heating up you have plant material. The essential oils come from plant material. So you have the plant material such as leaves or the actual flower petals, and you break it down into small pieces. You place it in this boiling flask, and with a little bit of water, you have this separatory funnel that also has extra water in there. So when you heat up the boiling flask, you don't want to heat it up too much. You want to use the boiling point of water versus the boiling point of the substance, because you don't want it to decompose. As you heat up, you want to make sure that the rate of the water coming out of the funnel is the same rate as the water going through the distillation system and being recondensed. So what happens is the plant material contains, in the solution you have water, then the plant material contains non-volatile compounds and volatile organic compounds. What happens is once you heat up, you'll have water vapor come through the system, go through the cooling apparatus, and then it'll recondense into a liquid. The non-volatile substance will also do the same, and it will leave the volatile organic compound will also do the same, and the non-volatile will stay in the boiling flask. Once you get as much of the volatile organic compound from the system as you can use a simple liquid extraction to recover all of your oil from the water. And this is how you retrieve essential oils. And also, a lot of times they will add essential oils into the wax of candles. So once you burn the candle, since a lot of them contain, since essential oils contain volatile organic compounds, they will easily melt and vaporize into the air, and that's how you are able to smell their aroma.